Hi everyone, this is a video that I wanted to do particularly on the interception kind of problems with vectors. We've covered this before, but I wanted to go through this problem specifically. This is a problem on the textbook on page 83. My approach might be a little bit different from the one in the textbook. So we've got a Coast Guard vessel A and we've got an oil tanker B. So I'm going to use our formulas that we know for the equation of a line, the vector equation of a line, to express these two. So the Coast Guard vessel, first of all, is at a harbour, and the position vector of that is -1,6. And it's going to go off on a velocity in the direction AB. Now we don't know what AB is. That's what we're going to try and find here. We're going to try and find what direction or what velocity the Coast Guard vessel needs to set to intercept the oil tanker. And T here is going to be time in hours. Okay, so let's get the units all right. These vectors are kilometers, and we're talking about a velocity vector in kilometers per hour. Okay, so that's going to be time in hours. Let's look at the tanker now. We know the equation of the line that the tanker is going on. It's starting at 17, -6, and it's heading off at 4.7 is its velocity, kilometers per hour. Okay, so this is right at the same time at 6 AM. So if there's a difference in time here, you might need to adjust this one here about where the tanker might be if the Coast Guard vessel took off an hour later or something like that. But in this case here, it's both 6 AM. So we know where the exact moment where the oil tanker is and where it's going, and we want to know where do we have to go to intercept it, knowing that we can maintain a speed of route 370 kilometers an hour. Okay, so like the other questions, in order for this Coast Guard vessel to intercept, that means the X values must be the same. Okay, so that's me just putting the X values the same in both equations. So if I can rearrange this now, let's put the 18 over here, and on the other side we've got TA minus 4T. So it's just A minus 4 lots of T. Okay, just check that that's right. So I know that in this case in this case here I want to get A on its own. So let's go AT minus 4T equals 18. So AT is equal to 18 plus 4T. So A is equal to 18 plus 4T divided by T. There's our value of A in terms of T. Now I can do the same for the y coordinates. 6 plus T times B is equal to the y coordinate for the oil tanker is -6 plus 7T. Okay, so -6 plus 7T. Okay, you with me now? Alright, so I'm going to subtract 6 from both sides, giving me -12 over here. I've got TB minus 7T. Of course, I want to get B on its own, so I should have just left it there. -12 plus 7T, and then I've got B equals -12 plus 7T divided by T. Right, there's my two expressions for A and for B. Now what do we know? We know that our speed has got to be route 370 kilometers an hour. And I know how to work out the speed. It's just taking these components here, squaring them, and taking the square root, kind of thinking Pythagoras' theorem. So now that we've got those two there, we can say, change to red here, A squared B squared, square root of those is equal to root 370. That's the speed that we can go at. So in other words, A squared plus B squared is 370. Cool. And then we've got expressions for each of those. 18 plus 4T over T. And the expression for B in terms of T is going to be -12 plus 7T over T. and that is equal to 370. This is where we get our CAS calculator out to help us find the value of t. Now, hopefully, if I've done everything correct, you're going to get two solutions for t because it's a quadratic equation. We're going to ignore the negative solution. So 1.2 should be one solution. So t equals 1.2 hours. Once we know the value of t, we can then substitute that value back into here to find A, and substitute it in here to find what B is. And if we do that, we should get A equals 19 and B equals -3. So therefore, the velocity that we need to go out on to intercept is 19 -3, or you could say 19I minus 3J.